if we have an integral with an absolute value, here's one way to handle that. If we look at the graph here of this one, y equals absolute value of x, that can give us some clues or some help with this. Now, we could do this with just triangles, but let's talk about how to do it without interpreting as triangles. But all right, so I'm going from -5 to +2. Well, what we can do here is use one of the properties of integrals. One of the properties of integrals said that if I had from a to b f of x dx, I can split that into two integrals. If I pick out a c value kind of in between a and b, usually is what we do, I can split it into that two separate integrals. And so that's what I'm going to do here, is split this integral into two separate ones, first of all. Now, where I will split it, of course, is at this corner. For the absolute values, that's where typically you want to split it up. So I'm going to go -5 to 0, and then 0 to 2. Now, the other thing is, when I do that, what I can do is split my absolute value also. Remember, this goes way back. Remember we talked about writing the absolute value in terms of a piecewise function? You could either say absolute value is minus x, or absolute value of x is just x, depending upon where you are in the function. And it's negative x if your x is less than 0, and positive x, I guess, or just x, if x is greater than or equal to 0. Remember doing that? And so in this case, what I can do is also rewrite now, change that absolute value over to one of these in those two. Now, if I'm going -5 to 0, which part of the piecewise am I on? I'm at the less than 0 part, and so I would do the minus x. You see that? If x is less than 0, I can replace square root of x, absolute value of x by minus x. And that's where I am on this part of it. On the other part, 0 to 2, I'm just replacing the absolute value of x by x. So let's go ahead and do that. So that gives us a way, because we haven't talked about, well, what's the antiderivative of absolute value of x? Well, we don't have to do the antiderivative absolute value of x if we split it up into these two pieces, you see. So that's what we're going to do for these absolute values, is split them into two parts. So yeah, now it's just a simple, that would be antiderivative would be -1/2 x squared. Do that from -5 to 0. And this would be 1/2 x squared from 0 to 2. Evaluate those two things right there. All right, so this, you plug in the 0 first over here, and then subtract, plug in the -5. Right? And then over here, we'll do 1/2 2 squared minus 1/2 0 squared. All right? Of course, 0 squared is 0, so that's going to be 0. Minus, that would be -1/2 times positive 25. So, yeah, that's going to give you a positive 25 halves, or 12.5. Over here, we'll have 1/2 times 4 minus, that would just be 0. So half of 4 is 2. So we got 25 halves plus 2, that is 14.5. With me there? Is that okay? All right, now, of course, what can happen, do a couple more of these because a couple more little complications. If I do -6 to 5, absolute value of x minus 3 dx. Again, if you look at the graph here first, that's, of course, the absolute value shifted 3 units over, but on this one, I'm not going to break it up at 0. Where do I break it up? At the corner, at 3. So, going from -6 to +5, I break it up at 3 instead of 0. So it's not just necessarily always going to break at 0. It's wherever that corner is. And so I go -6 to 3, plus then 3 to 5. Now, the other thing is, well, what am I going to replace the absolute value of x minus 3 by in each of those parts? Well, one of them is going to be the negative of x minus 3, and the other one's going to be just x minus 3. And if it's just a regular absolute value like these are, it's pretty easy. I mean, this side is going to be the minus, and then that side is going to be the positive. So this would be the minus of x minus 3, and this would be just the x minus 3. Okay? Pretty straightforward on those. Which that's, best way to do that would just say, that's the integral of minus x plus 3, distribute the minus, and then do your antiderivative, which would be minus 1/2 x squared plus 3x, evaluated from your limits. And this over here, a little easier, it's just 1/2 x squared plus minus 3x, 3 to 5. That intermediate step there. With me there? All right, so this will be minus 1/2 times 9, plug in the 3 first, plus 9, minus, then plug in the -6, that'd be negative 1/2. Negative 6 squared would be positive 36. And then 3 times -6 is negative 18. Get there. Then over here, we have 1/2 of 25 minus 3 times 5 is 15. 5 plugged in. Plug in the 3, we'll have 1/2 of 9 minus 9. Yeah, so we got negative 9/2 plus 9 minus a negative, that'd be negative 18 minus 18. Whatever that gives me. $40.5 is what I get here. Over here, on the other hand, I've got 25 halves minus 15 minus 9 halves minus 9. So what does that give me? Two. 42.5. So 40.5 plus 2 is 42.5. Okay? Now one little quick check on these, because these areas that we're talking about on the absolute values, you're always going to have positives because it's always above the x-axis. These two intermediate values, a quick check is those should be positives. If they're negatives, you're got something a little wrong there. But anyway, let me do one more here because it has another little complication, and that definitely comes up on the homework here. It's this one. The absolute value, integral -1 to 3, of the absolute value of 4 minus x squared dx. Okay. Well, if we look at the absolute value of 4 minus x squared graph-wise, here's what we get. Kind of a W-looking graph. And we're going from -1 to 3. Well, the -1, this is -2 here, so -1's here. And then +3, this is 1, that would be at +2, and then 3. So what I'm looking at is this to here. That's what I'm trying to find. Well, fairly easy to see. I'm going to break this up at the 2, where the corner is. So -1 to 2, and then 2 to 3. That's where I break it up. So break it up at 2. Okay? Now, you can't just assume then, like on the previous ones, I had this was then the negative of 4 minus x squared, and this would just be 4 minus x. That's maybe not the case. The way you can tell, or one way I say you can tell, if I just look at y equals 4 minus x squared, without the absolute values, you got this. And the way I like to describe it is, the pieces over, for the absolute value 4 minus x squared, the pieces that get negated are the ones that are flipped up. So here's what I mean by that. So this is 2, this is -2. The pieces that are negatives of 4 minus x squared are the pieces that get flipped up. So from this graph to this graph, which pieces get flipped up? Well, it would be this piece and this piece. Those are the ones that get flipped up. You know what I'm saying? They're down here without the absolute values. With the absolute values, they're up here. Those pieces are up here. So what I'm saying is, if I had a piece out here or a piece out here, these pieces would be the ones that are negative. And then in here, that piece is not flipped up, so it's just straight up 4 minus x squared. All right? Now, in this particular case, though, I'm only dealing with, from -1 to 2, I'm dealing with the 4 minus x squared. And then, so that's what I'm saying. This first one here is 4 minus x squared because it's not flipped up. Whereas the 2 to 3, that's the piece that is flipped up, if you will. So one way to look at it. It's a little different than our previous ones, but anyway. That's the way I look at it. All right? All right, so now we just do our antiderivative. That'd be 4x minus 1/3 x cubed for the antiderivative. Over here, that's negative 4 plus x squared, so the antiderivative would be negative 4x plus 1/3 x cubed. Which is just the opposite. We're going to do those for those limits. Three upper limit, 2 lower. All right, so now what do we got? Well, for this one, we plug in the 2 first. That'd be 8 minus 1/3 times 8, so that'd be 8/3. Minus, then plug in a -1, that'd be negative 4. Minus 1/3 times -1 cubed is -1, so that'd be plus 1/3. Then over here, plug in the 3 first, that'd be negative 12 plus 1/3 times 27. And then plug in the 2, so it'd be negative 8, 1/3 times 8, so it'd be plus 8/3. That's what we get. So let's see. 8 minus 8/3 minus then a negative 4 plus 1/3. Gives me a 9. In this part, negative 12 plus 1/3 times 27, and then minus 8 plus 8/3. 2 and a third. So we got 11 and 1/3. All right? Or is that 34/3? Probably how they write it in the back. Questions and concerns on that? Look okay? All right, let me finish off this section. This one doesn't have an absolute value. A couple of points I wanted to make on this. Find the area enclosed by y equals x squared, y equals 0, and x equals 1. There's our graph. Let's draw the graph to kind of get the feel for this problem. So y equals x squared is our little parabola there. Y equals 0, that's the x-axis. And then x equals 1. I'll make it a little, scale it a little bigger. Is vertical line through 1. And so find the area enclosed by all 3 of those. We're talking about this little piece right here. And now that we know what we know that piece right there, that would be the integral of x squared. And our upper and lower limit would be x equals 0 to x equals 1. So it's just evaluating that integral to figure out that area, which is 1/3 x cubed from 0 to 1. That would be 1/3 times 1 cubed minus 1/3 from 0 cubed. That's 1/3. So yeah, there are problems they ask about similar to that. But the other point I was going to make about this, isn't this right here, isn't this the first area that we were approximating when we very first started talking about area under curves? This was the first area we approximated. And you know, we approximated it with right-hand endpoints and then with left-hand endpoints. And then we looked at that, I don't know if you remember, we did that table where you had values of n, like 100 and 1,000, and it gave us those, and we looked at it, in a limit. And we said, well, it looks like that limit is approaching 1/3. Well, here's our verification. Now that we know how to do this, we figured out that that area is definitely 1/3. And that's what we thought it was going to be, but now we've got confirmation through our little technique that we know, so I wanted to throw that in. All right, any question?